Page 185, question number 14. A pendulum consists of a 500-gram metal ball, so we have a mass of 0.500 kilograms. So take the 500 grams, divide it by 1,000 to convert to kilograms. We have a string 50 centimeters long, so it's going to be a length of 50.0 centimeters. It's pulled up a vertical distance of 10 centimeters, so that's a height of 10.0 centimeters. It's then released. At the bottom of the arc, the mechanical energy is 0.491 joules. So our mechanical energy is equal to 0.491 joules. And we're asked what is the velocity or speed at the bottom. Now, to sketch this out, we're going to have our ceiling up here. We have our bob, that is the mass on the end of the pendulum. And we know that the length of the pendulum is 50 centimeters. Now we know that it's going to get pulled up to the side so that the height from the bottom position is going to be 10 centimeters. It's going to be released and it's going to swing down to the bottom. Now when it gets to this bottom area, our height is going to be equal to 0 because it's the lowest point of its swing and we're looking for the velocity. So when we take a look at this, our mechanical energy will be our kinetic energy plus our gravitational potential energy. Now because we're looking at the bottom, our height is equal to 0, that gravitational potential energy is equal to 0, so our mechanical energy is equal to our kinetic energy. So they gave us the 50 centimeters for no particular reason. We could talk about the mechanical energy at the start, but made up of the gravitational plus the kinetic at the start. But since they gave us the total mechanical energy, as it falls down, the mechanical energy does not change. Nothing's doing work to remove mechanical energy. So when it gets to the bottom, that mechanical energy has stayed the same, so it's all got to be kinetic energy. So our mechanical energy in this case is going to be equal to the mass times the speed squared divided by 2. So rearranging for velocity, we're going to have 2 times the energy divided by the mass, and then we have to square root the whole thing. So our V will equal 2 times our mechanical energy, 0.491 joules, all divided by our mass, 0.500 kilograms, and we square root the whole thing to calculate our velocity. So we grab our trusty calculator again, and we go square root 2 times 0.491 divided by 0.5 gives us a value of 1.401427843 meters per second. So looking at this, we use the mass, 3 significant digits. We use the mechanical energy, 3 significant digits. These have 3 as well, but they don't matter because we didn't use them anywhere in the calculation. So our velocity needs 3 significant digits, so 1.40. The 1 does not cause the 0 to round up, meters per second as a final answer.